Hello, my name is Eamon Scullion, and I'm a staff software engineer at Bazaar Voice. In today's talk, I'm going to be speaking about change data capture and how you can use it to turn your data into events. So applications today have a lot of moving pieces. Data needs to be kept in sync across your various systems. In this example, we have things like databases where you might not just have one node, you might need to sync data across many database nodes. It might be search engines where it allows you to search over the latest data with tools like Solr or Elasticsearch. You may have caches where you're using it for reads and you need to keep it up to date. So you might do things like invalidating the cache or inserting new items. And you might have analytics, so things like data lakes and data warehouses where you'll be using data there for reporting reasons or analytics. And you may also need to keep in sync with your consumers and other teams that might use your data. Without events, we would likely have to use a batch or a pull-based process to check what data has changed and to sync those changes with other systems. This approach introduces performance concerns as data may not always be fresh, and the more ETL processes that we introduce, the more our databases will be overburdened. This is especially relevant for legacy systems, which may have existing performance or scalability limitations. If we look at the example we have here, we have an application and we're doing all of our writes to a database, and to sync the changes to other systems, we're having to pull on an interval using ETL processes, and then those separate processes update their respective systems. So this is where change data capture comes in, also known as CDC. It's a technique to capture and stream data changes, allowing event-driven architectures to consume and react in real time. This pattern works well alongside event-driven architectures, as we can listen to changes and trigger downstream consumers, or even replicate the data across different domains or services. Compared to the previous pull-based approach, CDC allows us to move towards a push-based or publish-subscribe approach. In this example, we can see we're doing all the modifying operations like inserting, updating, deleting, and then change data capture takes care of how we update our other systems. So what is CDC used for? The primary reason to use it, one of the prime use cases is replication. So you may have a series of replicas rather than one database. So you might replicate data across your different database nodes, allowing you to balance your database workload better. Another reason is keeping systems in sync. So some examples we mentioned before is you might want to keep your search indexes up to date so you get all the latest and freshest search results. You might have materialized views where you're calculating pre-computed views so you don't have to do so many dynamic queries. And likewise, you might have downstream systems you want up to date. It also helps you collaborate across domains where you can filter, enrich, and produce events to allow your external consumers to react in real time. Defining events will help you to stay decoupled from different domains. And then lastly, another reason to use it is it allows you to integrate with legacy systems and enables a path forward for modernization or migration. So why would we use it? Firstly, it allows us to be decoupled, where event filtering and publishing is handled by your database and streaming services, allowing it to easily be modified in the future without affecting your applications. An example of this is if you chose one technology for streaming, in the future you could switch to another one and your applications wouldn't be affected. There's also simplification in that by using dedicated services for this, we have less custom code to write. All our applications have to care about is writing to the database, and then change data capture takes care of publishing those events. There's also efficiency reasons as well, like Being able to stream allows us to react to changes in real time, so other systems will have access to fresher data. In the previous poll-based approach, it might run on an interval, so your data might only get up to date every 30 minutes or whatever you've configured, whereas streaming gets us as close to real time as we can. And by using CDC events with the exact changes that consumers need, we can minimize the amount of database queries that we make, further reducing the pressure on our database. We can also add additional consumers with little to no overhead to our existing applications and databases. So how does CDC work? Your database system has something known as a transaction log or an operations log, and it's a rolling record of all the operations that have modified your data. Typically, it stores the previous 24 hours of operations, but it can be configured to store a longer history. With this transaction log, we're able to stream changes to our data in real time, and we'll refer to those as change data capture events. Some example technologies that use this approach are DynamoDB streams, MongoDB chain streams, and Debezium for MySQL. So how does it work? With our stream of changes, we can examine our change documents to determine the events that we want to publish. Depending on your use case, you may want to further filter these events and only publish specific events. You may even want to enrich them or translate your events to make them easier to consume. Note, it is recommended to not tie your events too closely to CRUD operations or anything that leaks application internals. Your events are your contracts with your external consumers, so focus on business events to provide more context and minimize coupling. So what are some considerations to think about when we're designing or implementing a change data capture system? Using MongoDB change streams as an example, we can see a CDC event for an update operation. On the right, we can see the operation type is an update. We can see the exact updated fields that have been changed. We can see any removed fields, and we get a lot of metadata that's quite internal to this application. To produce this event, we have performed an operation to modify a products document to update a quantity field. So you can see that updated in the, you can see that set in the updated fields section. Using CDC in this way, and extracting these changes from the op log or transaction log, we're able to determine the exact changes that have occurred to the data or the state. And this makes it a lot simpler to filter out what things we want to create events from. CDC can also be configured to contain as much or as little information as you want. For example, you may have a use case to see the exact change that has occurred, but you may also want to include the full representation of the new state and even the old state before we made the change. This kind of flexibility makes CDC suitable for even more use cases. And for your implementation of CDC, you should consider how you expose these events to external consumers and the types of events that you use. So what type of event is right for you? CDC events can be thought of as delta events. We store the difference between the old state and the new, and we're focusing on sharing just the changes. Depending on your use case, you may want to alter the contents, so you can use things like thin events or fat events. Thin events, these are events that only contain a reference or ID, and they can be thought of as a notification. You're notifying your consumers that a change has happened and they have a reference or ID that they can use to look up the information, usually via an API. This approach is more suited for applications that need fresh data or fresh data is essential. And by making an API call, we can make sure that we have the latest version of that data. Another positive is that our events are smaller, so there's lower bandwidth concerns and lower storage overhead. And because the events are so minimal, the contracts are less likely to break in the future, as we're only storing references and not containing full attributes or fields. Some downsides of this is scalability concerns, in that as the number of consumers grows, so does your API calls. If you aren't careful, then a spike in your traffic might overload your APIs. And by calling APIs, we're going to be coupling consumers to your APIs rather than your events, which is something to consider. On the other hand, with fat events, these are events that contain enough attributes that consumers need in order to lighten the workload for the consumers. They will typically contain data that is changed, as well as the full state of the data. The goal of this approach is to give consumers as much data as they need, so that they don't need to make an API call to fetch anything further, but the option is there if you need it. And they're best suited for use cases that are okay with eventual consistency. Things will be in sync eventually. It might be real time, it might be minutes delayed, but it'll eventually be updated. So some of the pros with this approach is we have better decoupling. We're setting up contracts with events, and we can focus on that as how we integrate with consumers. And in this approach, consumers can operate completely independently of their producers. And there's less overhead for consumers, where you're giving the events in the most suitable format for consumption. Some cons of this approach is data could be out of date by the time it's being consumed. It depends on how often you're updating your data. And deciding what you store in your event might be a challenge. There's a lot of risks around events becoming huge and messy. So if you're going to use this approach, then you should consider using something like an event schema or versioning to avoid any kind of breaking changes in the future. And the other downside is bigger events means more storage and more bandwidth overhead. Another thing to consider is, in what way do you translate your events? Do you take them at face value, what your database is giving you, or do you do any translations to make it easier to consume or hide some of the internals? In some of the examples before, I showed MongoDB includes a lot of internal fields. Here might be a stripped down version of that, where we're only including the fields that are relevant in this circumstance. And yeah, this is also to help ensure event schema is more flexible to change or evolve in future. If you included every field possible, then it might make it difficult to remove fields in the future or add any additional ones. So putting it into practice, here's some examples of how you can use CDC today. So let's say we have a mission critical legacy application that we want to rebuild in an event-driven architecture. And as part of this, we want to make sure there's minimal downtime and minimal migration overhead. Reasons for doing this might be you're migrating from on-premises to cloud. You might be migrating to a new language or framework. You might be migrating from a monolith to microservices, or you might already be using a cloud, but you want to revisit your architecture, maybe bring in some event-driven elements. Some things to know about this system is that we write data to multiple places. So we've got a cache, we've got a search engine, we've got data warehouse. So let's see how CDC can help with some of these challenges. By leveraging CDC, we're able to simplify our application by moving the event logic to the database and streaming services. The stream can be filtered so that consumers listen to only the changes that they need. For example, search can filter for only the attributes and changes that it needs for its search queries and search results. So if we walk through this process, we have a legacy application on the left, which has all of our services, and we're performing writes to the database, and we're streaming all of our operations, all the changes that we've made. And then we have something after the stream to filter those changes and figure out what events do we want to create based on this change. And then we're sending it to an event bus, which our consumers will be listening to specific events that they care about. Another aspect of this is the common problem of migrations is doing a big bang release of doing all the building work to replace every element of a legacy application. And it may take months, it may take years, but the problem with this is that you're not releasing early and you're not getting feedback. So you might end up building the wrong thing. One way we can work around this is splitting our application up into slices of functionality features, which we can replace and migrate at a time. This allows you to release early, get feedback, and iterate on it. So in this example, we might have 3 services in our legacy application, but we're only going to replace one to start with, and we'll slowly migrate things over. We can add new features to the new architecture while still supporting the old, and the data gets synced across, so it doesn't have any impact on users or customers. Another example to mention is that serverless is a great fit for CDC and event-driven architectures. One reason for that is it offers pay per use, and it takes away a lot of the operational burden of setting up the streaming, filtering, transforming, and publishing of events. By leveraging serverless in this way, we minimize the amount of code that we need to write. So in this example, we have a DynamoDB table where we're writing our orders to, and we've set up a few Eventbridge pipes. These pipes allow you to filter, transform, and publish events. So we're filtering for each specific change that we want. It might be a order created, order updated, and then we're publishing those events to Eventbridge, where consumers can read them from. Using in this matter, there's very little that we need to do as users, and a lot of the heavy lifting is done by AWS. So to summarize, change data capture is another tool in your EDA toolkit. It allows you to react to changes in real time and provides a path for migration and modernization. When implementing CDC, you should consider how you want to represent your events internally and externally, whether that's adding some sort of transformation logic or filtering to figure out what you share internally in your domain or externally with other domains. And some useful resources to learn more is Serverless Land, which has a focus on event-driven architecture, CDC, serverless, built around AWS. And another is Minimum Viable Migrations by Ben Ellerby. This will give you more details about how event-driven architecture can help you with your cloud modernization. That's the end of the slides, and I'm happy to field any questions in the chat. Thanks for watching.